To Eduxcite classes. In today's session, we will start topic 5, paper 1 MCQ. Okay, so let us start. So very first question, if you see two identical sphere conductor X and Y are mounted on an insulated stand. These are the insulated stand. This is conductor X and Y having a charge of plus 8 nanocoulomb and minus 2 nanocoulomb. Now two conductors are brought into contact and are then separated. Which of the following gives the charge on each conductor? Now we know that when they first are made into contact, equal distribution of charges takes place, and that too very instantaneously. So if I say, let us say plus 8 and minus 2, so net charge is plus 6 nanocoulomb. So what will be there? On X there will be plus 3 nanocoulomb, and on Y also plus 3 nanocoulomb. So option D is the right answer. Okay. Now question number 2. The diagram below shows a positively charged rod. This is a positively charged rod. Okay. This is brought near an insulated uncharged metal plate. Now you see this is a positively charged and this is an uncharged metal plate. So uncharged means equal number of positive as well as negative charges. So if a positive charge is there, so there will be an induced negative charges on this side, or you can say the concentrated of electrons will be towards the positive rod side, and automatically there will be a deficiency. There is no movement of positive charge because they are inside the nucleus, but we can say if electrons move towards one end, there will be an overall deficiency of negative on the other side, so we can call it as positively induced part of the plate. So now look at the result option. The metal plate will gain there will be no gain. The metal plate will remain uncharged. Yes, so it will remain uncharged. The equal number of positive and negative charges will be present. Only a distribution of charges will take place. Okay, now question number 3. An isolated uncharged metal conductor is brought close to a positively charged insulator. So the same thing will happen. This is positively charged, so negatively charged will be here, and automatically positive will be distributed here. Now this is earthed. Okay, now this is earthed. Earthed means as soon as the conductor is earthed, what will happen? It will see there is a positive, and because this positive and this negative are attracted towards each other, so they are not free to move. So what will happen? The abundance of electrons are there in the earth, so they will start to move to nullify this, cancelling this positive charge. Okay, so for a very short period of time, these electrons will cancel out these things. So it will be one positive, one negative will cancel out each other. And then if you disconnect this, okay, if you disconnect this, then you remove the insulator charge away, so there will be an equal distribution of negative charges all over the conductor. So if you look at the option A is the right answer. Okay. Now question number 4. X and Y are two identical conducting sphere separated by a distance d. X has plus 6, Y has minus 2, and the electric force between them is plus F. Okay, so we know that F will be equals to what? Or anyway, it is not required. So what is there? The electric force between F is attractive because one is positive, one is negative. The spheres are touched together. There is a physical contact and they are separation again to the same distance d. Now the force F will be. Now we know that F is what? K Q1 Q2. So initially F is 6 into 2, that is 12. Forget about microcoulomb upon d square. So this is F. Okay, now when they touch together, so plus 6 minus 2 will be equals to plus 4. So equal distribution as I mentioned. So the new force F dash, let us say, will be K, which will be 2 into 2, that is 4, divided by again d square. Now they will be of same nature there, so there will be a repulsion. So automatically we can say if the attraction is positive, repulsion will be negative. So these two are incorrect. Now you can say what is the relation between this is 3 times of this, or you can say F dash is F by 3. So you can say F dash is F by 3, so you will get K4 upon d square. So which is option minus F by 3. Okay. Now question number 5. There are equal charges x, y and z. The distance between q1 and q2 is 1. q2 and q3 is also 1. The electric force between x and y. Okay. Now x and y I can say like this. Let us say all point charges are of q. So the force F is what? K q square upon 1 square. Okay. So the electric force between the charges x and z will be, now we know that x and z is what? This, which will be root 2 times 1 Pythagoras. So the new force F dash will be K again q square upon root 2 square, which will be K q square by 2. So this is K q square, so I can write F by 2, which is option A. So question number 5, option A. Now this is the direct definition. The electric field strength at a point may be defined. This is the force. Electric field strength is what? E is Q, F equals to QE. So E will be F by Q. So F upon Q, that is the force per unit. This is per unit charge on a small test charge. Force per unit positive charge on a small test charge placed at a given point. Okay, so option B is the right answer. Now question number 7. Two positive charges P and Q are held at a certain distance apart. At which point could be the electric field strength due to the charges be 0? Now always whenever you're supposed to find out the electric field strength, just put a unit positive charge, test charge there, and see how it is happening. So what we can say is, if you put here or at x, so due to positive this will repel and this will also repel, so both are in the same direction, not possible. Here also not possible, so only is this position where if you put a positive q, it will, due to q it will repel, and due to p it will, so they will get cancelled out, so it will be 0 at B only. Okay. Now question number 8. 2 point charges of plus q and minus q are fixed at the position shown below. At which point again the electric field most likely to be 0. So we have to give an approximation here. If you see at A, if I place a plus q, so there will be here only, at here this will also be in this direction. So A and B are not option. Now we have to think about C and D. Now C is very close to both the charges, so it will not give the 0. You can check with any certain values, or you can count the number of dashes as well. So only option is D is most likely to be 0, where the electric field between the due to that two charges plus 2 and minus q will be 0. Okay. Now question number 9. The diagram below shows two parallel plates. Conducting plates are oppositely charged. So this is a parallel plate, you can see. The line x and y is perpendicular to the plate. Okay. Which of the following diagram shows the variation along the xy of the magnitude E of the electric field strength between the plates? Now as you move along the line x and y, how should the electric field strength will vary, that we have to check. Now if you look at the options, the given 4 options, now we can clearly state from this, like if you look at the x and y, again put a positive q charge. Due to positive q it will get repel here from repel here. Okay, so and it will attract in the overall it will be in this direction. Okay, so again if you have put at this point, again it will be in these two directions, resultant will be in this direction. So whatever be the charge you put along the xy, the electric field strength has to be the constant, and in that too in the same direction. Therefore option D will be the right answer. Or you can directly remember, it is a uniform electric field and the electric field strength is constant throughout the distance between the two parallel uniform parallelly charged plates. Okay. Now question number 10. In the circuit below, n charges carries the point P, pass the point P in a time t. Each charge has a charge q. the current. Now we know that current is what? Current is charge per unit time. So if n number of charge carriers are passing and each charge carrier, so n q by t. So that is the definition only. So option B is the right answer. Now the drift velocity of the electron in a copper wire in which there is an electric current is, now what is the drift velocity? Okay, that is nothing but the drift velocity of the electron in a copper wire in which there is an electric current is equal to the speed of light, close to the speed of light, or of the order of. Now we know that electrons are not moving at all, they are just drifting. So when we are drifting means they are just moving a small distance. Okay, so all the electrons are suddenly applied the potential difference, the electric current is flowing, so the electrons just drift from their place. It means they are covering a very small distance. So you can say it is of the order of few millimeters in per second. Okay. Now question number 12, which of the following is the correct definition of electric potential difference between the 2 points? Now again guys, you should know each and every definition because IB generally asked in MCQ as well as in paper 2 as well. So you should be very clear about how to define what are the key terms. Okay, so it is very specific. So if you look, it is the work done per unit charge to move a small charge between 2 points, because it is asking between the 2 points. So option D is the right answer. And electron volt is nothing but it's the unit of energy first of all, which is equal to 1.6 into 10 raised to power minus 19 joule. So 1 EV is equals to 1.6 into 10 raised to power minus 19 joule. This you have to remember. Okay. Question number 14. Which of the following is the correct value of the electron volt? Again, the same answer. Electron volt in SI unit. So electron volt is the unit of energy and energy's SI unit is joule. So again the option B is the right answer. I hope it is clear. An electron volt, it is defined as, sorry, for question number 13, the electron volt is defined as the energy gained by an electron when it moves through a potential difference of 1 volt. This is the unit. It is asking the definition. My mistake. For question number 13, the answer is C. It is electron volt is defined as the energy gained by an electron when it is given a potential difference of 1 volt. So in 1 volt, how much energy is gained by an electron? That is 1 electron volt, which is equals to 1.6 into 10 raised to power minus 19 joule. Okay, so just check for question number 13. Answer is C, not A. Sorry. Now question number 15. There is a current versus voltage graph is given for a filament lamp. Now filament lamp is not a ohmic resistor, but for this question if you consider at 4 volt, okay, now the resistance of the filament at 4 volt will be what? Resistance will be what? V by I. You just check at 4 volt. If I zoom it at 4 volt, it is something here which is 16 if you see. So just you have to do 16 upon current is 10 raised to power minus 3 guys. So this is 16 into 10 raised to power minus 3. So this and this gets cancelled, that is 1000. Okay, so sorry, this is V is 4 not 16. So this is 1 by 4. So this is by 4, which is 250 ohm. Option A is the right answer. Although it is like guys, we know that it is not a ohmic resistor, so we cannot officially practically apply V equals to IR. But at a given instant, just for the graph, because the graph is given to us, we can apply this formula to get the resistance of the filament at 4 volt. It is not the same because the resistance will change here, but at 4 volt we can apply the Ohm's law. Okay. Now question number 16. There are 3 resistors. Current I in 3 resistors are X, Y, Z. Which of the following correspond to a resistor for which the resistance increases with increasing current? Now you see here resistance increases with increasing current. Which of the following graph is the most suitable? Now if you see here, the V versus this is the Ohm's law. So where the resistance does not change, so Y will not be the option. Okay, so this is incorrect. Now look at X and Z, what is happening. Now if you look, this is I versus V graph. Okay, so I versus V graph, and you see the gradient is decreasing. So this is I by V. Now if you see here, the gradient is decreasing, here the gradient is increasing. So x is what? Gradient is decreasing, it means the ratio of I versus V is what? Which of the resistors? The resistance increases. Now resistance is what? Resistance is R. R is what? V by I. But for this will be 1 by R. So if gradient is decreasing, it means resistance is increasing. This is the gradient. If this value decreases, it means R is increasing or not, with increase in current. So option X will be the right answer. Try to analyze this equation. 1 by V will be 1 by R, because R is V by I. So it is the reciprocal. So the gradient is the reciprocal of resistance. If the gradient is decreasing, then the reciprocal will increase. So the resistance will increase with increasing current for only X. Whereas for Z, resistance is decreasing with increase in current. Okay. So option A is the right answer. Now, which of the following is a correct statement for Ohm's law? The resistance of a conductor is constant only provided the physical condition such as temperature is constant. If you are changing the temperature, then the resistance will change. Okay, so option D is the right answer. Direct question. Question number 18. An element of an electric heater has a resistance R when in operation. What is the resistance of the second heater that has a power output 3 times as large as the same operating voltage? Now if you look at question number 18 now, R, when what is the resistance of second heater? Now if this is having a power output, let us say this is R1, this is power P1. So power output, second heater has a power output 3 times of that of the power P1, operating at the same voltage. Now we know that power is what? V square by R2. So this will be what? 3 times of V square by R1. Now the voltages are given in the question as same. So I can say this and this gets cancelled. So this is R only. So R2 will be what? R2 will be 3 by R2 will be R by 3. R2 will be R by 3, which is option B. Okay. Question number 19. Two circuit X and Y below. Each cell has an EMF E and negligible. Each resistor has a resistance R. The power dissipated in the circuit X is P. Now P is what? E square by R. Now here it will be R and R. So resistance will be what? Resistance will be R by 2. So this will be 2 E square by R, which is 2P. Option C is the right answer. Simple direct question. Now this is a good question. So in the circuit below, the cell has a negligible internal resistance. Okay. Now which of the following equation with respect to the currents are correct? Now for this, first of all, you have to analyze the equation. Look at the circuit diagram. The I1 is going out, and this is I2 and this is I3. So first equation I can say I1 is equals to I2 plus I3. Yes or no? Okay. So now what I can say is, if I find out the R equivalent, so 1 upon R equivalent is equals to 1 upon R plus 1 upon 2R, which gives us, if you calculate R equivalent, you will get 2R by 3. Now when 2R by 3 is the equivalent, so what will be the voltage? Let us say this is voltage V. So voltage V will be I1 into 2R by 3. So and I1 we calculate. So I1 we can say and I2 will be what? Now I2 will be V by R, because these are what? In parallel. These two R and 2R are in parallel. So I can say I2 will be V by R. So V is what? V is I1 into 2R by 3 into R. So R and R gets cancelled. So I2 is 2I1 by 3. So we get a relation between, or you can say 3I2 is equals to 2I1. Is this relation given? No. So what we can do is, now for I3, if I say I3 will be V by 2R, again V is what? I1 2R by 3 into 2R. So this and this gets cancelled. So we get 3I3 equals to I1. Now you compare this I3 and I1. So what I can say, 3I3 is equals to I1. So 3I2 is equals to 2 times of 3I3. Okay. So this 3 and this 3 gets cancelled. So I2 is equals to 2I3. Now check for this. I2 equals to 2I3. So the relation for this is I2 equals to 2I3 is option C. Okay. So this is quite, you have to just use the Ohm's law, series parallel equation, and equate the I1, I2 and I3, you will get the answer. Now question number 21. The resistors in each of the circuits shown below has same resistance, increasing total resistance. So we know that for total resistance, let us assume these all as 6. That will make your question easy. 6R, 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 6R. All resistance are of 6 times of R. Now you just check, you will get your answer. Okay. So 6, 6, 6. If all the three resistors equal connected in parallel, so divide by the number of parallel combinations. So 6 by 3 is 2. 2 plus 6 is 8. So this is 8R. 6R, 6R is 12. 12 and 12 is 6R. 6R, 6R, 3. This is 3R. 3 plus 6, 9. 9 plus 6, 15. So this is 15 now. So maximum is of S, increasing. So minimum is of Q, then P, and then S. Option B is the right answer. Okay. Now question number 22. In the circuit below, which meter is not correctly connected? So we know that ammeter is correct, voltmeter is in parallel, ammeter this. So option D is the right answer. Question number 23. A battery is connected in series with a resistor R. The battery transfers 2000 coulomb. So charge is 2000 coulomb and resistor is R. Completely rounded during the process, energy is given to us 2500 joule is dissipated in the resistor R and 1500 joule is expended in the battery. So this is for the resistor R and 1500 in the battery. Okay. The EMF of the battery will be, now for the EMF, now EMF is what? EMF is the total, you can say the potential, maximum potential difference that a battery can give to the circuit, including the internal resistance, obviously. Okay, so we know that this 1500 joule is in the what you say, in for the internal resistance. Okay, so we can say the definition of potential difference is the work done per unit time, work done per unit charge. So work done is total energy dissipated, which is 2500 plus 1500 is 4000 and the charge is 2000. So this gives you 2 volt. So maximum voltage will be 2 volt. Okay. Now question number 24. The reading on the voltmeter will be this voltmeter. Okay, so the circuit is connected as shown. The voltmeter has 20 kilo ohm and the battery has an EMF of 6 volt with negligible internal resistance. So the reading on the voltmeter will be. Now if you see for these type of question, you can consider this as very this is 20, this is 20, so this will be 10. So 10 plus 10 is 20, so 20 kilo ohm. So reading on the voltmeter, this is 10. So 3 and 3 will get deficient. Here also it will be 3 volt because this gives you 10 kilo ohm. So equal resistance, so equal dissipation of the potential difference. So here also 3 volt and this will also read the 3 volt. So option is B. Okay. Now question number 25, this is a good question. In which one of the circuit is it possible to vary the current in the lamp? I want the current in the lamp to be varied by adjusting the variable resistor. This is my variable resistors. Okay. So cell has a negligible internal resistance. Now if you look at the option B, these are connected in parallel. So this will have a certain, now for current what will be the V by R is the equation. Okay. Now this V, if this is also V and the let us say lamp has a resistance R. So here the current will be V by R. There is no other option to change. Okay, there is no effect of changing. So this is incorrect. Here also they all are connected in parallel. So V by R again. So this is not the correct option. Now we have to think in terms of A and C. Now if you look C, what will be the current here? Let us say this is voltage V and this will also get voltage V, and this there will be distribution of voltage for this resistor and the lamp. Now let us say the X is dissipated here. So the voltage available for the lamp will be what? V minus X. So current will be what? V minus X upon this resistor R. So is there any role of this variable resistor? If I change any resistor here, does this affect the current flowing in this lamp? No. So option A is the right. Now how option A? Again, if this is V, so here the distribution of voltage will take place. Now here the voltage, let us say this X. Now this X will depend upon the R equivalent. Now R equivalent has this R also. R of variable resistor. This is R. So here the current will be what? V minus X upon R. Now this X depends on R equivalent. So if X changes, this current changes. So option A is the right answer. I hope you got this. If you have any doubt, you can just comment below. Okay. Now question number 26. This is, I just put up the values and you will get the answer, like how the best estimate. Now we know that what should be the internal resistance. We know the current, we know the resistors. Okay. So if I say the current is I equals to V by R. Okay. Now R will be what? R will be R series, because this and this will be in series. Battery resistor, the resistance, internal resistance of the battery will be in series with this resistor. So if I put 1 ohm, so 1 plus 1 is 2. So let us say V is equals to IR. So I is 2 and this is 1 plus 1. If assuming this as the answer, so this will give you what? 4. Now this should be the same for this also. So I is 1, 4 plus 1, which gives you 5. So this is not the answer. Now check for B. If I put here 2, so 2 plus 1 is 3 into 2 is 6 volt. Here if I put 4 plus 2 into 1 is 6 volt. Yeah, so definitely B will be the right answer. Directly you can solve, or you can put the equation for your internal resistance and then also you can check for the answer. This is the short, like in minimum time you can solve just putting up the values and you will get the answer. Now in this question number 27, there are 3 resistors. One is variable resistor which can be varied from 0 to 3000. We have to find out the maximum range of the potential difference V across these 2 points. Now let us say this is 0. So this will be 3000, this will be 3000. So 4.5 volt here, 4.5 volt here. So it will start with 4.5 minimum, and maximum voltage it can reach is, like if this is 3000. So this is also 3000, 3000, 3000, 3000. So 9 divided by 3, which is 3 volt, 3 volt. So 3 volt here, 3 volt here. So the potential difference will be what? 6 volt. So it will be from 4.5 to 6 volt, which is option C is the right answer. Okay. Now this is a very tricky question. Question number 28. Earth's magnetic field and geographical north and south. So we know that this is geographical north pole. So if this is the north pole, so Earth's south pole is attracted towards the magnetic geographical north pole. Okay, so this is the south and this is aligned only at an around of something around 21 degree. so not this, and these two are incorrect. Okay, so option A is the right answer. Always remember, the magnetic south pole of the earth is towards the geographical north pole. Then only you can see now, if you put a compass needle, the compass needle is made up of magnetic material. Okay, so that magnetic material is showing towards you the north, so that north is aligning with the south, then only it will attract. Now, are you getting my point? If you have any doubt, just comment below. Now question number 29, if you see a current carrying solenoid, a small compass is shown along the axis. Now this is at an angle of 45 degree with the axis of solenoid. The current in the solenoid is now doubled. Now doubling the current, what will happen? The magnetic field at that particular point will also increase. So let us say the magnetic field right now is in this direction. So it is something around like it is forming a these type of curve here. So doubling will have a steeper like this, so the angle will become steeper, which is B. So the field lines will increase and it will be expanding much more. So if it is expanding much more, then the angle will get more steeper. So option B is the right answer. Question number 30, it's a direct question using a right hand thumb rule. Current in the wire is into the plane, so if you curl your fingers, it is what? Question number 30, if you curl the current is into the plane of the page, so it will be curled like this. Okay, so option D is the right answer. Why not option C? Because they are very what do you say, equally spaced, but that is not happening. Near the wire, the current magnetic field is stronger, and as you move away, it becomes weaker and weaker. So option D is the right answer. Okay. Now question number 31. Two long vertical axes X and Y are carrying a current in the same direction. So you should know that in the same direction they will attract each other. So if they attract each other, then these types of iron fillings will be supported. This is repulsion. They are not in concentric. So always along a wire there is a concentric circles, magnetic field lines are forming. So for attraction, these two will be the they will join together at this point and there will be nothing here. So it will be option A is the right answer. Okay. Now a strip of aluminium foil is held between the poles of a strong magnet as shown below. So you just use your Fleming's left hand rule. Direction of current north to south. Direction of magnetic field. This is force, this is magnetic field, this is current. Okay. So put north to south as this finger. Direction of current in this, so you can see it. If you plot it on a paper, you will see that thumb is pointing out of the plane, so you can say vertically upwards. This is Fleming's left hand rule, okay, to find out the direction. Now magnetic force acts on an electric charge in a magnetic field, so you should know that it should be perpendicular, so it should be at the right angle to each other. Magnetic, that is magnetic force on a QVB sine theta, if you remember the formula. Force exerting on a moving charge in a magnetic field. So if they are along the magnetic field, there will be sine 0, either parallel or anti-parallel. So theta will be 0, sine 0 is 1. So no force. If a charge is not moving, velocity is 0, then also no force. So the maximum will be when theta is 90 degree, and theta is the angle between the magnetic field and the motion of the charge or the velocity. Okay, I hope you know this. Now the charge particle is entering into a magnetic field. How does the kinetic energy and the momentum of the particle changes? We just have to answer in terms of change or unchanged. So basically charge particle, when it enters, it will deviate. Okay, now if the charge particle is moving inside this, so it will experience a force. Now charge particle is moving in this direction, magnetic field is into the plane, so it will move like this. So momentum is what? A vector quantity. If the direction changes, then the momentum changes. So this is incorrect, this is incorrect. Now we have to think in terms of kinetic energy. Now kinetic energy is what? Half mv square. Now we have to see if v is changing or not. So we know that force is acting, but force is perpendicular to the you can say to the motion or the velocity So if the force is perpendicular, there is no work done, because fd cos 90, then it will be 0. So no work is done on charge. If no work is done on charge, so the charge will not gain, no gain of energy, then there will be no change in kinetic energy. So option C is the right answer. It's a conceptual part. You should know that force is perpendicular to the direction of the motion. So if the force is perpendicular to the direction, then f d cos theta, that is the work done. Work done becomes 0. Work done is 0, then there will be no work energy principle. No work done, no energy change. No energy change, therefore kinetic energy will remain same. Therefore unchanged kinetic energy, and due to change in the direction, there will be momentum. Kinetic energy is not a vector quantity. Okay. Now here, this is also a direct question. The two parallel wires I and 3I current are shown. The force on wire 2 due to wire 1 is F. So the same amount of force will be act on wire 1 by wire 2. So it's a action and reaction pair by the Newton's third law. If one force is acted by one wire, the same amount of force will be acted by the second wire on the first wire. Because if you look at the formula, although it is not in your IB, it's U naught I1 into I2, that is the product of the current in both the wires. Okay, so if 1 into 3I or your 3I into I you do, you will get the same answer. Okay, so the same force will be exerted on one another. Now for this, you can use the shake hand method I generally use to calculate the direction of the forces exerting between the parallel wires, or you can just remember a simple rule. What is the rule? If the current are in same direction, then they will attract each other, or if the current is in opposite direction, then it will repel each other. Okay, so you can see here, this is moving in this direction, this is moving in this direction. So we have to find out the resultant force on wire Q. So due to wire P, it will attract each other in this direction. Okay, now for wire R, they both are in opposite direction, so they will repel each other. So it will move here and it will move here, so this will move here. So overall resultant on the wire Q will be on the left hand side, and that too in the plane of the paper. So option D is the right answer, in the plane and of the paper towards the left hand side. Now question number 37. A straight conductor is placed in a magnetic field. Which of the correct expression of the magnitude of magnetism? We know the formula. If a current carrying wire is placed in a magnetic field, the force is F equals to BIL sine theta. This is, I think, given in a data booklet as well. Okay, now it is given that the force per unit length on the conductor due to current in the magnetic field is P. That is, F by L is given to as P. So P will be what? B sine theta. Okay, so B will be what? Bi sine theta. So P will be what? B will be P upon I into sine theta, which is option C is the right answer. Okay, I hope it is clear. Question number 38. Now if you look at the charged particle is moving in the direction of the magnetic field. So if it is in the direction of magnetic field, there will be no force exerted on the wire, on the charged particle. So it will move without any deviation. Option A is the right answer. Okay, it will only experience a force if it has a certain angle with the magnetic field. Otherwise it will no force exerting, so it will pass without any deviation. So the last question of the day, question number 39. An electron is traveling in the direction shown and enters a region of uniform magnetic field. Now always remember, whenever you are using the Fleming's right hand or left hand, the direction of the current is always the direction of positively charged, or the charge moving is the positively charged. So if electron is giving, we'll consider the charge in the opposite direction. So magnetic, using the Fleming's left hand rule again, magnetic field, direction of magnetic field is towards downward. This finger will be in the opposite, that is like this. Okay, so it is downward. Magnetic field is like this. If you draw it on a piece of paper, it is like this. Direction of positive charge is like this. So thumb is moving in the upward direction, so it will be out of the plane of the paper. Option B. So I hope I have cleared all your doubts related to topic 5, paper 1 MCQ. If you have any doubt, you just comment below. Also, you can find out the PDF of this video. The link is given in the description below. Please share with your classmates so that it can reach to the maximum, and it gives me a motivation as well. Thank you. Keep learning.